Good morning, ladies and gentlemen. Hope everything is well. You guys are staying safe, healthy, wealthy, and wise. Let's talk a little bit about computer-aided design, CAD, and I'm going to show you a couple of the CAD software that we experimented with in class, as well as hopefully walk you back through how to open them up, how to get started, your credentials, using your school account, and so forth. All right, so let's go ahead and talk about a brief history of CAD drawings. All right, in our CAD, we are going to talk quickly about a very brief history of CAD, only pulling out the high points. CAD was started in 1957 with a program called Pronto. Now this was a program, this was the origin, this was the genesis of CAD and computer-aided design drawings. It was built by a guy named Patrick Hanratty, and it was the first commercial numerical control programming system, which would later in turn spark everything that we know as CAD today. All right, don't forget that. That was 1957. So over 60 years ago, 63 years now, since CAD drawings were first invented. All right, if we could fast forward through many other inventions and improvements into the CAD system. In 1982, Autodesk, the company Autodesk, it was the first set of software built where you could draw 2D designs, and they were made for PCs instead of a mainframe, huge mainframe computers or mini computers. All right, this was basically the 2D drawing in a much more efficient manner. All right, fast forwarding again many times. We're going to go all the way up to 1994, skipping many important innovations. But in 1994, that's when Autodesk, the program, was first made 3D compatible. Well, that's important to us because we draw everything. All of our 3D CAD drawings now can be done in 3 dimensions. That's the software that we've used, both Tinkercad and Google SketchUp. Those both obviously made to do 3D drawings. All right, and then Autodesk 360 basically moved CAD to the cloud. So in the early 2000s, Autodesk 360 became the first program to use mainframe CAD backup software that was tied directly into cloud servers. All right, this is important to us because it allowed the huge file sizes from CAD drawings to be minimized and marginalized a little bit by being able to save them on cloud firmware hard drives. All right, and into cloud processors. All right, if we're moving on, we're going to look at SketchUp first. Now, we're going to go through again quickly how we go and we log in. Remember, because of your PCSD account, you should have a Trimble account. So let's go up to the top right. I've already signed in. So what it's going to do, hopefully, is just go ahead and take me there when I hit Try SketchUp. You're going to use this for personal use, is the easiest way to get in there. And remember, this is the free version online. All right, your interest, you can pick any of them. I'm just going to do architecture here. I'm going to agree to the terms of service. I'm not going to send me SketchUp news and tips because I don't want them sending stuff to my inbox necessarily. And then we're going to go to continue my apps. All right, we have these options over to the left. You can click SketchUp for the web because that's what you're using, but it's going to automatically go there if you'll just click Start Modeling here on the right. As we load up here, we have Google SketchUp. We're just going to go through a few of the main controls for Google SketchUp, how to draw some of the symbols, how to resize them, how to push-pull, and several of those things. If we can get this to go ahead and kick off, would be better. Until then, we wait. All right, we don't want to open it. We'll start new here. We're going to go then to start modeling, but before that, let's go to our template, feet and inches. We just want to make sure that's highlighted. It'll automatically kick us to a new one. We're just going to go here. This will save to your Trimble account. We can just go, you'll see our bookshelf there. For this name, let's just do test model. We're going to go to save here. All right, we can delete her. She's of no purpose for us, and at least in this scenario. Remember, all your push-pulls, if you're not using a traditional mouse with the center mouse button, are available over here. We can go to the hand tool and then click the hand tool. All right, and then we can come back. If I can get it to highlight there, and for some reason it is not. Let's see if we can get it to do it. Let's get back out of there. Go back in. Now let's see if it'll give us the hand tool. There we go. Just a little glitch in the system. You can remember you can zoom in and out. We're going to go ahead. We're going to go back to the rotate tool. We're going to click to pull over. We didn't really get the rotate tool there. But that's good enough for our purposes. All right, so let's just go ahead. Let's start with our symbols here. If we want to align perfectly with the red axis, we just draw that out from the red axis. You'll see the mouse, the cursor click in place there. Let's say we wanted to make this a dimension of, let's go 4 feet. We'll do more. Let's go 10 feet by 10 feet. And that should have us there. We'll zoom in a bit. All right, we're going to use the push-pull tool there. We're going to grab, if we can select it, and we're going to pull that shape up. All right, so that's our square. We're going to go back. Remember, the circle's in the same section as the square. Let's go ahead, draw a circle here. We'll make the radius of the circle 10 feet. Let's click and select the box. Let's move it out of the way if we could. All right, a little big on the circle. Let's go out, let's give it a little bit of extra room here. All right, and then we push our push-pull tool here again. Very similarly here. Remember, if we're wanting to, we can put circle on circle, square on circle. We can come over here, draw another circle in the middle here. Most of you guys, that's not centered, but it's good enough. Most of you guys remember how to do the simple instructions, the simple things. We're going to go here. We're going to push-pull that. If we wanted to push-pull the center instead. if we wanted to push pull the center, we could just select the center. All right, so that's our push pull tools. We have our varying shapes. Let's say we want to measure from one end to another to ensure that our shape is the right size. That one's 2 and 6.5. Good enough for us. All right, for the current time being. So remember, that's Google SketchUp. We can do anything. You have your freehand tool. You have your paint tool. If we want to throw a little paint on the box here, we can. On the circle, we can. All right, that is Google SketchUp. All right, on Tinkercad, remember, we can just sign in as well. We'll go to sign in with Google. We're going to go ahead and we'll get in to our account here. Let's go to create new design. Remember, this is the 3D design software. This is the one where we actually drew the shapes were pre-made. We can resize them. Remember that our view block is here. If we want to see from the top, we can. Rotation from the sides, we can. That's the right, looking at it from the right side there. Front, we can see all angles, including the bottom. All right, we're going to leave it roughly at the top. If you'll double click it, it'll automatically adjust for you. All right, let's go, instead of 20, let's go 60. Let's see if it'll hold that. There we go. Let's over here. Let's go to 60 as well. All right, that gives us a fairly large block there. That's going to be 60 inch by 60 inch square. All right, our sphere, we can go ahead, put that there as well. Let's try out a couple of shapes. Remember, all the shapes are right here. You can do that as a solid or a hole. We'll mess with that in just a second. A roof. In case you're trying to draw some more intricate stuff, let's say we want to drag that to 25. Let's go 30 by 30. See if we can. You can also resize everything by simply dragging on the resize handles. Let's say the ball, we want it to be 30 squares. Well, 30 and 30. There we go. Just as easy on this to just go ahead and click and type in the box. That'll let you resize things quicker. Color, let's say we want to make this solid instead of a solid blue. Let's say we want to make it just one of a tan color. Let's go with there. Let's say the roof we want to be was that solid black there. And let's say the square we want it to be a nice green color. All right, all those things we can do. All right, looking at the square here, let's say the square is something we want to mess with. All right, we only resized it in 2 dimensions. There's still a 3rd dimension here. Let's say we want it to be 60 as well. So now we have a 60-inch cubed. All right, 60 by 60 by 60. We're going to rotate back up to the top. Let's say we want something even more awesome. Let's say we want to put a cylinder hole in the cube. All right, it's going to be, let's say we want to throw it in down there. For the hole, let's try this. Let's take the guidelines. Remember, when we're dealing with Tinkercad, we use our guidelines, our work plane, and that basically allows everything we do to be on the correct plane. Let's put the box hole right there on the top of our plane. That's a hole. All right, we could resize as necessary, but we now have a hole that could be easily resized. All right, we're going to put that with the box as the hole. It would need to be on a corner. All right, but it will work. Okay, we're going to delete that out. Let's do something. Let's put some letters on there. Let's see. What about an initial? Let's get that there. Good and centered. For there, we'll go up here to the Tinkercad, the dialog box here. Let's go to, if we can find text and numbers. Let's go to, let's say somebody's first initial was D. Let's say their second initial or their last initial. We'll just go, maybe their middle initial is fine. DCE. All right. Those blocks are there. We can recolor them any color we want to. Let's get the green. Let's keep the green from being green. Let's go back and let's make it a nice dark red maroon color. All right. We can take the work plane down by flipping down. We can put that work plane over here instead. Straight back down to the bottom. We can also resize those letters. All right, remember we can zoom in there. We can resize them. Take each letter. If we want them to be flatter, that's at 4 inches off the top of the face. We can go down to 1 to give it a slight raised appearance. Now remember, when we're having things raised, it's very, very important to use the work plane for this, because this system is designed for 3D printing. If you don't 3D print, if you don't design correctly for the 3D printer, what will happen is the 3D printer will assume that you wanted these letters to be hovering over the box. You don't want the letters to be hovering over the box. You want the letters to be in the box. So it's very, very important to get that done correctly the first time, because if you were to 3D print this and these letters were actually up, all right, these letters were up a little bit off of the face because you just guessed and tried to put them in there, then that would try to print in a 3D way, which means basically it would be trying to hover above the box, and the 3D printer can't do that. The 3D printer is only going to be able to print on surfaces. So if it would start at the mat, it would print this up, and then it would keep printing this. If these letters were somehow floating and not perfectly on the box, the 3D printer would just give you a bunch of goo up here and just a big mess, because it would be trying to levitate or float those letters up above the box, which is impossible for a 3D printer. So be very accurate and make sure that you know exactly what you're doing, and that you have checked and double checked your work, making sure that these letters are on top of the box. All right, so that's just a quick overview of Tinkercad and SketchUp. Have fun with it. Remember, 3D printing is something that is incredibly useful in today's world. CAD drawings are incredibly useful in today's world. They save architects, builders, engineers. They save them thousands and thousands and thousands of man hours a year, because they keep everything perfectly consistent, and they allow the builders to do things. The architects, engineers, they allow them to do things online that can quickly be changed, as opposed to things that would take tons and tons of time to be manually redone. All right, you guys have a great rest of the summer, and I look forward to seeing some of you on campus again next year. See you.